In this video, we'll consider what electric field lines look like when there are multiple charges involved and also the forces between those charges. So we considered two charges, one's positive, one's negative. There's nothing else in the universe. First thing, add field lines. Field lines can start at plus or infinity. They can end at minus or infinity. So this time we can have the same type of lines we had before, starting at plus, going to infinity, starting at infinity, and coming back to minus. So those type of lines can exist, but we can also have field lines that start at the plus and end on the minus. And if we come out here, there can also be a field here. We have to draw a field line that starts on the plus, ends at the minus, and is as smooth as possible. So that would be a smooth curve from here back to the minus. We could draw a similar one here and more out here as well. So there we have what the electric field lines look like for this is called a dipole, a positive and negative charge that are close to each other. Alright, what direction is the force on the positive charge? Well, let's see. We know that the force on the positive charge is in the direction of the field. In this case, if I look at the positive charge, the field appears to be going out in all directions. So we actually can't answer this question from the way we drew this. Can you tell? No. Alright, let's try something just a little bit different. Now, both charges are positive. Add field lines. They can start at positive and go to infinity. So again, we can do a couple of them like we did before. So going from this positive to infinity, going from that positive to infinity. Those are both fine. Before we had field lines going in between because they started on the plus and ended on a minus. We can start one like that again. So if I start the field line here, I can't curve it back around to here. It's going to have to go out to infinity. So it can go like that. And another one can come from here and do the same thing. I can draw more like that out here and down below. What's happening here in the middle? If I try to come out this way, I'm going to run into this charge. I'm not allowed to do that. So anything that comes in here is going to have to curve out like this. So there's no way that you can put field lines exactly in the center. They're going to all curve away from the center point. What direction is the force? Again, what we wanted to do was to look at the charge and say, whatever direction the field is at that point, that's the direction the force is on a positive charge. But for this one, it appears to be going out in every direction. So we can't really tell. So if the field lines are going to be useful for finding the direction of the electric force, we need a new way to draw them. Let's try this time with this positive charge, and then this one we're going to call a test charge. So first we'll imagine what is the field like with this charge present and this one not there at all. We're looking at the field only of this charge. It looks something like that. So if this one weren't here, the electric field would look like that. Now the question can be, if I were to put a charge here, I drop a test charge into this point. I do not draw field lines for my test charge. I just ask, if it were there, what direction would the force be? And now we can say, all right, I know that the field from this one points to the left. So if I drop a positive charge here, the force will be to the left. And finally, we get an idea of why the field lines are helpful.